Good morning, everyone. My name's Kyle Andrus. I will be your MC for day 2 of Converge and B-Sides Detroit 2020 edition. Our first speaker this morning is Brad McMahon, who will be talking about Would You Like to Play a Game? CTFs. And I leave it to you, Brad.
Morning to all of you in the States, and probably good afternoon to you guys in Europe. So this is a talk just about basic intro into CTFs. If you've already played several of them and you kind of run up constantly against the wall, this might be a good talk for you. If you're experienced, you know what you're doing, and you might get a little bored with this. So let's dive into it real quick. Who am I? My nickname or handle is Nullspace. You've probably been talking to me in the chat, or you've been talking to me on Twitter. I hate bullet points, but unfortunately, this topic doesn't allow me to not do bullet points on something, so just bear with me on that. I am part of the CTF 313 crew. I help make several of the challenges, along with several of the other guys. There's about 6 or 7 of us in the crew. You're curious how I kind of got into this. It's because I've kind of touched on so many different areas in IT and security. So I've touched a lot of different areas. So that kind of got me into making all these various challenges. So this is the current, if you're not playing, and if you want to get into the CTF, this is the game's website. I would highly suggest you go there and enjoy some of the easy challenges, and then start hitting your head really hard against some of the hard ones. Like I said, what is this talk? It's a general run through of CTFs and general what to expect. I cannot tell you or guarantee you that this will be useful for all CTFs you play, but I know definitely for several of the ones that I've played in the States, this is you gotta be a pretty good kind of a 101 into it. So start, capture the flag. It's noun. It's basically a hacker competition. It puts your mind against others' minds in one way or another. Why play this? Well, fabulous prizes, bragging rights, and just showing off your elite skills to maybe to a potential employer. Like, I've heard people say, hey, yeah, I got 1st or 3rd place at this CTF. And if your employer recognizes that, great. That's probably a good idea that you want to work there. And if they like big whoop, then oh man, it's pretty big red flag. Maybe this isn't the place you want to work. It kind of helps. It's just one of those trophies you get to show off. So there's 2 kinds. There's Jeopardy and there's attack and defend. We're mostly going to go into Jeopardy, but I will touch on attack and defend. So attack and defend, essentially like a war game scenario, cyber war, if you will. And you basically will set up, you'll be attack and defend sometimes all at once, and you'll have a crew of people who are the red teamers and the blue teamers. Blue team's trying to defend, red team is trying to attack. And sometimes you are just the blue team, like CCDC. That's a collegiate challenge where they're forced up against actual experienced red teamers, and their job is just to be defense, to just sit there, lock the code down, put the firewalls up, start patching stuff. Jeopardy. Jeopardy is what CTF 313 is. It's a lot like the game show. There are no podiums except maybe your laptop. You could consider that. But this is usually, it's a lot easier to get into this. The attack and defend, you really need to have experience and know-how. Otherwise, you're just not going to be effective. This, you can kind of muddle your way through. Google can help you a lot of the times. It's usually less stressful. And we just like it because it really helps ramp up the difficulty level. So what to expect? I love this scene in Dune. What's it about? Pain. Expect pain. There's going to be I keep saying this, the lower points, you know, they aren't meant to just be like tearing up your mind. They're usually 1 or 2 step kind of thing. The real pain is the ones that are high points, where there are multiple layers to it. They're meant to make you think differently, and they kind of hurt, but it's good. It's like what I heard, a sweet pain, not a bitter pain, and not hurting yourself here. You're just helping yourself grow. And that's really why we like doing the CTF, because it helps us watch people kind of grow. It's likewise, we learn a little bit from the attendees as well. So some CTF basics for to go through. Everyone's like, hey, where's the flag? What's the flag? What's the flag look like? You know, flags usually have this, I know with the more difficult ones, we will put flag equals or flag colon, or flag is literally verbatim. And sometimes you're just staring at them on the simple ones because you're looking for this flag, and it's just the simple challenges they're just too easy, too simple. And if we just put flag in there, it just becomes, you know, some of it loses the elegancy to it or some of the historical significance to it. That is why we don't always put flag in there. It just doesn't work with the challenge. So, and we always keep those on the lower end of them. And we always try to make it very overt, like it's clear. It's English. It is some, you know, usually when you hit English text, you're in the last leg, you're on the last step. You just need to figure out that last piece to it. What are we meaning? What are we driving? So, like I just said, read the clues. Read the clues. Sometimes the clues are buried into the challenge themselves. So you get some English. That's a big clue. That definitely tells you you are on the right track. We don't really put rabbit holes in where we go, ah ha ha, you're in the wrong area. So now you got a flag. Let's get some points. How do we get points? Well, once you signed in and you're into the game, go to challenges. You click on one of the challenges. There's a challenge name, the challenge question, and you put your answers in there and you click the submit button. Pretty simple. Solving the challenges. First, gotta kind of take a step back. Little computer science 101. Some people are getting tripped up on this. When you see this stuff, that's what this is. You got binary, it's ones and zeros. Octal, it is literally, you can only go from 0 to 7. That's what it does. It transfers down the data down into that base. So that's why we call it base 8. There's only 8 digits in it. Decimal, 10, base 10. Sometimes you'll see it as ASCII code characters. How do we get base 10? Why is it the most common? Look at your fingers, look at your toes, 10. That's why. Hex, one of the more common things we see all within computer technology, and often how it's pretty easy for us to view things is in hex, like a hex editor. That's base 16. Some basic data types. If you hear me say string, that is just a combination of characters that just appear. It's basically how we put English text or our own human language into a computer program or into a challenge. Character is a single one of those. Now, character could be, and just like a string, numbers can be in a string. A character can be a numeric, or it can be a symbol. Integers are just whole numbers. They're just numbers. Float and Boolean, I wouldn't worry too much until you start writing some code, but those are just some good things to go through. Computer science, it's mostly math. I know some of my challenges, I started to really get more into a bit of math. Prime numbers are key for encryption and understanding encryption. If you want to learn more about encryption, learn how prime numbers come to be. More things to learn: number sequences, algebra, geometry, efficient algorithms. These are all handy things. Number sequences like Wood's numbers, Fibonacci sequence. These are things that we may or may not put in our challenges. And discrete math. There are sometimes we throw some discrete math into it, some logic, some number theory stuff. So encoding versus encryption. Encoding is not encryption. I don't know how many people keep thinking, oh, base 64, it's encryption. It's not. You got to think of it more of like file format changes that we're used to, like AVI to MP4 or an AAC to MP3 or a WAV to MP3. That's really what it is. It's totally reversible. Hashing. Hashing is really meant to be a one-way algorithm, a one-way math program that derives your string into a just a bunch of numbers and letters based off that math. These are considered infeasible to be reversed. It just takes too much math to go backwards. So usually you can defeat these with a dictionary attack, hash or rainbow tables, or just brute forcing. Encryption is meant to, it's hashing and encryption kind of merge a little bit in some ways, because they're both kind of based off some math and some algorithms in order to make something difficult. But typically encryption is where you incorporate a password or some kind of passphrase or something to lock it down. So there's a secret that's needed. That it could just not be a password, it could be a cert, or it could be a special particular algorithm inside the math that it needs to kind of complete it. But it's usually there's something secret that you need in order to get that. So let's go a little bit more into encoding. Base 64. This is a base 64 table, basically how it'll convert things into it. I would try to not do this manually. I would try to use a program. There's a great tool out there called CyberChef if you want to take things in and out of base 64, or learn your library that has base 64 in your coding language. So what does it look like? It looks like this. A lot of people say it's pretty indicative that you're looking at base 64 when you have this garbled a string and there's an equal sign at the end of it, or sometimes multiple equal signs. That's not always true. Sometimes you get a base 64 string, there is no equal sign, but that, we decode it and it gets us this. Encryption. Now, RC4 encryption is pretty weak encryption. It can be broken, but we had to end up using a key for this. And so that's key to the part of that's encryption. We needed to use some kind of secret. In this case, it was secret squirrel, and we decrypted it and we got up and at them. So how do we crack RC4? It's not reversible. Well, let me Google that for you. It's, I guess, a bit of a mention on this talk. I'm not going to go into super details of how do we crack hashes and how do we crack passwords. This is a 101. So it's just to get your feet wet, just to kind of whet your appetite. Go out there and learn more. So how do we crack hashes that don't have a massive vulnerability in them, or some logical failure in them? Well, you can do hash cracking. You're going to need a graphics card or pretty powerful CPU, and you're going to want to use John the Ripper or Hashcat. There may be some other tools out there. These are the ones I'm most familiar with. And if you want to know more about them, go online, learn about them. So how to know the difference between encoding and encryption, what's in use, what's in not. So one half is just kind of throwing it through the algorithm, throw it against the wall, see if it sticks. And if you get something out that seems reasonable, you're probably on the right direction. And again, you got to read some of the clues on some of the CTF challenges we give you. Read those clues. Those will help you kind of direct you where you're going. The other half, there's a signal in the noise. You will find something there that really leads you to understanding, like if it's ones and zeros, well, that's binary. Or this has got numbers 1 through 9, and it's got A's and S. Maybe that's hex. Or octal. Hey, there is no 8 in here. There's nothing above the number 8. 8 on up, nothing here. Okay, this is probably octal. So, and the third half, I know there's only 2 halves, but the joke is just that sometimes you got to think about things, history or online, or some cultural challenges. We'll try to make things a little fun. Like this time we made the Wu-Tang Clans, their first album that they released. We made a whole series of challenges that were inspired by them. So some of the challenges will require you to know a little bit more about that song or that area, and some of them are they're just a bit of an homage, but there's nothing in a challenge that has anything to do with it. It's just what you see is what you get on those. So you need to think. Encryption and encoding has been around for a long time. We can harken back to the time when the Grecian warriors, when someone from Sparta wanted to exchange information secretly, they took a piece of cloth, wrapped it around their sword's hilt, and wrote out the message, and then filled in the rest of that cloth with just a bunch of garble. And that's how they ended up actually making kind of a little bit of an encoding on there. It's a little keep something secret on it. It's not encryption, but these schemes have existed around, or a Caesar cipher, where you just change the alphabet, you move it by like a digit or two, or ROT 13 digits over. You can get, it's a little bit of a neat little trick to confuse your opponents. So let's go to Web Hacking 101. And again, it's 101. We're going to go through some very basic stuff. So if you've never really tried to do anything with web hacking, I highly suggest just open a web browser to a page that you pretty well know. Right click on the page and view source. Look at the source. This is not the code. This is not the PHP or the Python or the Java that they're running in the backend. This is what's called interpreted. It's been already parsed and interpreted. It's kicked out. This is HTML, JavaScript, and CSS. This is stuff that's meant for your browser to interpret and to display it in a meaningful way to you. So you're not going to go through some deep hacking here and crack their server through this code. You're not. Now, you can start to kind of understand the flow of the traffic back and forth. So if you you hit F12, or you open the developer console and you go to network, and you start to see how you interact with the website and how there's different network traffic. Now we're getting to somewhere. Now we're understanding how the client-server relationship works. And you look at what's the payload in those. There are a lot of times developers will put a lot more information going to the client than ever will be displayed. Sometimes they'll just put really stupid stuff like, oh, here, I'll take the entire database. I'll just dump it to the browser, and then I'll have the JavaScript sit there and just filter it out there. I've seen cases where people even have the client issuing SQL commands, and the SQL commands just basically go straight on through into the database. It can get immensely dumb. There are other cases where you can do with JavaScript. There's some cross-site scripting attacks that it's really key understanding the JavaScript there. So I've said JavaScript a lot. You don't know JavaScript, go learn it. If you can't use the tool you don't know how to use, you're going to it's unlikely you shoot yourself in the foot, but you're just gonna not have any kind of toe grip on this. You're not gonna get any leverage or moving forward on your hacking. Now, I'm going to take one more step back here. Don't do this against the server that is not yours. Do not play around with things. It's okay if you're being innocent. Do not do anything that you think is an attack. Don't try to just fuzz a random server. That's illegal. Don't do that. That's fuzz servers that you're allowed to fuzz. So maybe start up a web server at your own home or host your own website and do stuff like that, and play little attack rounds against that, or host Matilda, or there's a lot of other vulnerable websites that you can get kind of as a package from OWASP or from some of the other app security companies, organizations. Go to those, get those, and play around with them. Do not go against actual live websites. It is just a bad time, man. So we already started to touch on this. Think evil. First, go through as a user and understand how you interact with that server as a user. Now, think, how could I break this? How could this be misused? Start to think. It's called adversarial thinking, where you start to think like the adversary. This is even a great thing for blue team. If you're only doing in defense, this is a great thought process to think, hey, I'm looking at this person's code, or I'm looking at this website, how can I break this? How can I make this, and then we call this kind of white box, black box. We call this black box thinking, where you basically don't know the code on the back end. You start to make assumptions and you try to kind of piece it together. It's a black box because you can't see anything in a black box. White box is where you actually know the code and you know how it's running, and you probably drink coffee with the developer. So there's not a whole lot more into it that I can go on. It's really that you start to develop your own kind of methodology. Now, let's go into some tools. aside from your browser, which is a fantastic tool, and Notepad or Notepad++ or Sublime or something like that to just kind of write stuff down or copy the source and start to kind of tear through it, start getting a deeper understanding of things. Zap and Burp Suite. So first, Zap. It's a tool that basically has a bunch of these things that are great for web hacking. You can, when you first download it, you run it and install it, it can be a bit much. It can be very intimidating. So I highly suggest you go up on YouTube and you watch. This is a good link that just kind of starts you down a playlist, learning how to use Zap, how to set it up. If you don't like watching videos, read this article. This is a great article, introduces you to Zap. Zap is great because it's free and open source. It is run by OWASP. It is a project. OWASP is a open web standard application security group. I'm part of it. I'm a co-chapter at Oakland County. Sorry, co-chapter leader at Oakland County. Take a sip of coffee here. So yeah, probably one of your biggest tools is Google. Just look up stuff on Google. Hey, what's this? I don't know what this is. Hey, what's this JavaScript library? I don't know anything about it. Hey, are there vulnerabilities on this JavaScript library? Stuff like that. We talked about Burp Suite. Brian, another CTF crew member, highly suggested Burp Suite. I'm partial to Zap. He really loves Burp Suite. He's more of a kind of web hacker than I am. So maybe go with him. You can download it in that top link, and you can learn about the tool at their academy. At one time that wasn't free, and now it's free from what I heard. So yeah, definitely learn how to use that tool. Even if you start to kind of like, hey, I really like Zap, learn both tools, learn their strengths and weaknesses, get a good feeling for which one you maybe like. Sometimes that one of them is better than another. So I would try them both. They're good. So forensics, deep dark security art here. And Kyle may ding me on a few things that I may suggest here. But first thing is getting some file knowledge. Get to understand what the files look like besides what you see it as human. How does the computer see it? How does it read it? And the best way to go about that is by looking at it through a hex editor. So get a hex editor. There's thousands of them out there somewhere. So find one you like that isn't malware and open up your favorite files and see what makes them tick. And there's this thing called a magic number. It's the first digits in file, and that basically tells your file system or whatever that is actually reading it, this is my file type. I am a doc. I am a docx. I am a PDF. I am text files don't have them. Zip file. Zip file I think is actually the signatures at the end. So there's a little bit of oddity to it there. But yeah, the vast majority of these things have this magic number. So that's going to be indicative of what you're looking at. If sometimes people will they'll change the file extension and you're like, wait, this isn't a PNG. What the heck? What's going on? Oh, it's a doc file. That's strange. Or learning more about. So we can step away from the magic numbers, but start to understand a little bit more how a file works. There's lots of different things that certain files can do. So for example, there's this big XML standard that Microsoft started to put into play with all their new docx or PowerPoint-X or whatever. They're all zip files, except the PowerPoint one I don't think is a zip file, but Excel and Word, I know, those are actually zip files. They just compress them up and it's just a bunch of XML in there. So hey, go tear one open and see what's within all those XML files. What's going on with that? Really start to understand just how that whole file actually functions. So tools, I've talked about hex editor already. I mentioned Sublime and Notepad++. Definitely useful for just taking notes, or hey, I saw this interesting thing inside of this file. There's one thing here that's missing, but it's in the Linux command So files, handy. That actually tells you what the file system believes that this file is and all the details of it. But strings is a command that basically pulls out all the human readable strings that are in that file. That's great for forensics if you're trying to look for something that is hidden, but you don't know how it's hidden. Use that. That's really helpful. File analyzer, I found it pretty handy. It tells you a bunch of stuff. It tells you the CRC. In some cases, actually gives you like a whole like waterfall chart interpretation of what the binary looks like. So sometimes you get an idea where the flow of it is. It tries to actually deeply inspect it, actually interprets the magic number. It says, hey, it's really this, it's this type of file. So that's a quick trick that can kind of help you cut through a lot of the crap. Volatility is a memory forensics tool. So if you find a mem file, you will need to use volatility. There are other memory forensics tools, but this is one I'm most familiar with, and it is really handy, really powerful. So got a memory dump, use volatility. It's a big old, another complicated tool that we won't go into depth in using how, but it is definitely worth learning. File carving, binwalk, scalpel, FTK, bulk extractor. These are all file extraction tools that will help you. You think there's something buried inside this file. It looks like a zip file, but it's seeming there's some weird stuff at the end of it that doesn't look like a zip file, and you don't want to sit there and try to cut and paste this thing with Notepad. Definitely try to if you start to try and carve out things from other areas, don't use your hands, don't use a Notepad, use a tool. It's purpose built for these things to precisely cut these things apart and basically find where that data is. So that's a trick, is where people will actually concatenate files together, and it just looks like weird scattered garbage when you start looking at them. But if you cut them apart, oh, hey, yeah, that's a image file attached to a zip. That's strange. Who would do that? And another forensics thing is log analysis. That's pretty key. A lot of us who are in the defense area, we're living a log life. You're constantly reading logs. So Splunk is a fantastic tool. You can get it free for, I think it's like 50 megs per day. You can put it into it. So it's good to have that on your desktop. And just, if you want to be able, it helps you just read through the files a lot easier. It parses them apart, and reading logs with just a Notepad can be brutal, especially when we're talking like a gig. Your computer's gonna hate you, and it's gonna operate really slowly. I definitely use a purpose-built log analysis tool. Use Splunk. Binary analysis. Things get really hard from here. This is where a lot of specialized knowledge comes into play. The best I can suggest is just run the program. Literally just run it. See what it does. Does it have a help file on it? Does it have a man page? Does it? So many people are so quick to be like, oh, I got to reverse engineer this thing, and I got to pull out IDA or Ghidra. And if you don't know those tools, those are the learning curve on those things is huge. It's hard. I have a hard time reading these things and using them. So don't be so quick to just be like, I got to tear this thing apart, because reverse engineers don't do that stuff like in a day. It takes a long time of them tearing it apart, piecing it. There are maybe some challenges where they'll ask you to do that, but most of the time, if you're looking at a binary analysis CTF challenge, the idea is that you run it and you throw stuff at it and you see what it kicks out, and you just do this return oriented kind of like, sometimes you'll write a program around it and you'll base it off the returns you're getting on it. And so just try harder. Sometimes you don't need to, if it's not an executable, or sometimes it is an executable, that might just be some C#. And you can use a reverse engineering tool for that. There are tools that will basically take that binary blob and convert it back into C# for you. DLLs are that way too. Not all of them. some of these things are written in C, and they will not be kicked back out into C# for you. A jar file is a Java compressed. Basically, it's a zip file, but you can't just unzip it and like, oh, I'm starting to look at Java. There are some things that may be Java in there. There are other things that will not be Java. It'll be fully machine code. So use a Java reverse engineering tool. It'll kick it all back out into Java for you. This will save you a lot of pain and suffering. Java is a very popular language, so is C#. So heck, even in your Windows files, your Windows system, I'm sure there's some DLL, there's some executable in there that it's written in C#. Yeah, totally verse them, learn how they work. Yeah, I already mentioned fuzzing, and IDA and Ghidra and Binary Ninja. Great tools, but if you don't know how to use them, I would not try to. Maybe you want to try and learn them on a CTF. It is a cool environment to learn that in. They will try to make it a little easier, but I highly doubt a lot of them are expecting you to pull out a reverse engineering tool like this. And probably one of the more important things, the mind games we play with you. Us making challenges, we play games with you. We try to get you to kind of stretch and think differently. If it was the same thing you would see in your office, it's not so much fun, and it's not really a challenge. You've seen it before. This is meant to kind of sharpen your eyes. So different things we'll do. We'll put it in a Morse code, like you see right here. We'll put it into a different language, which this is, I think this is Gaelic. We'll put it into QR codes, and we'll put it into other various barcode variations to just kind of hide it, to add the additional layer of challenge and make you think things a little differently. Sometimes we'll reverse the string. Sometimes we'll do some weird math to stuff. We'll actually, I know some of the challenges I had to write up code for them because it's just that complicated, and I wanted to be very precise on it. So we'll play all these different kind of tricks on you. And yeah, there are definitely challenges there that have QR codes in them. I just said, I automate the tedious stuff on my side, making the challenges, fully expecting you to automate the annoying stuff on your side too, because some of the stuff is not meant for you to do by hand. It will hurt. Just like file carving, don't do that by hand. Definitely don't do that by hand. You're in front of a computer, and we're all expecting you to all have, probably your best machine. You're working on a CTF. Run that CPU, run it through its cycles, hit that, nail the memory. We got some big challenges out there that will really tax your system, and thus making it. I think I had a challenge where it was 1,000 QR codes, and one of the contestants was going through one by one with their phone and scanning them. And I'm like, okay, buddy, I'll see you next week. It's like, you will not solve this within this time. You need to automate this stuff. So I would say definitely learn programming language with that, even if it's just Bash. Lateral thinking. I think it's probably one, if you talk to anyone in InfoSec or anyone in IT that has been around for a while, probably one of the things they'll say that they really appreciate most is someone who can think laterally. Everyone's taught vertically. We're all taught, go A, B, C, D, go through these steps. But when you're going against an adversary, who they will think laterally. They'll have to, because they'll have to move, bob, and weave through your security. So likewise, we will make challenges that will make you go from one category to another category. That I will, oh, hey, you think you're in forensics and you're just going to find some basic strings. Oh, wait, now it's this Caesar cipher that's been base 64. I don't think you're going to see the base 64 probably and stuff when they're trying to do file exfil, or where they're trying to try and get something into your organization through the whatever security tool that's sitting there interpreting it. Base 64 stuff has been pretty common. So, but we try to get you to think that way, to expand your mind. It's kind of like people in high school, why do I have to learn this math? I'll never use it in my world. Yeah, so you're going to be a business person. You need to know calculus because it stretches your mind. It makes you think differently. It makes you a better thinker, a better person. Your critical analysis just grows. You just become just that better. Your mind is that sharper of a tool. So again, the caveat: some of the stuff applies to some of the CTFs out there. And sometimes it doesn't. Sometimes, each CTF is a little different. It's run by a different crew. So, but the points, when you're looking at low points, don't overthink them. I've talked to a couple people. They're on, the sub 5 point range, and they're hitting their head against stuff, and they're like, I don't get it. I don't see the flag. Maybe step back. Take a step back, reassert your assumptions. What are you looking at? Are you like over sanitizing the string we give you, where it's, you're getting perfect? That's not the challenge. The challenge is what we gave you. We purposely give you things. You're not there to try to like clean it all up. I mean, sometimes you look at a log file, yeah, you got to clean it all up. It could be a little hard to read. But if you're looking at very simple stuff, it's not meant to be hard. You got to reassert those assumptions, think simpler. But likewise, on some of the hard challenges, read the clues. What we gave you, we feel is enough. So you need to actually really read these things. You can't just burn right through them like, oh, I know what I'm doing. Because you're up against the wall and you're like, wait, I don't understand it. These things don't interconnect. That's on purpose. That's the lateral thinking. We want you to go from A to G and think, okay, and then go back to C. And it just makes you think differently. So those are just, I guess, a few clues on some of the challenges we have. So some thoughts, ideas, and ramblings I have. Look for what's unique or different. When you're looking at something and you don't know where to start, look for the uniqueness. Aside from reading clues, you may be midway through. Look for what's different. What is unique? What is strange about what you're seeing? Don't try to reinterpret it in your own way. Just try to see what is different. Make logical jumps. Go. If you're getting something from somewhere else in a file, and you're running up against like an encrypted string, this whole thing is meant to interrelate. This whole file or this whole package, this whole challenge interrelates in certain ways. So if you find something that's basically like, hey, I went down this area and I got this string, that might be a password. That might be a key. That might be an IV to your encryption. So, but these things, we don't do these things just for rabbit holes. They're there for a reason. Sometimes just throwing stuff into CyberChef and just playing around with it, you solve it, and you get some serendipity out of that. And take the win. A lot of times people just throw that in the CyberChef, or they'll throw it through their own code and see what kicks out. Go with it, yeah. Especially if you're stuck and you don't know, just start throwing random stuff at the wall, see what sticks. If stuff is stuck, definitely, I would always say different coding programmer techniques like rubber ducking, where you say the problem out loud, or just you go back to the beginning and reassert your assumptions, go step by step by step, go through that. That's good. Sometimes you just got to get away from the computer. Go have a coffee, go have some tea, go drink some water, go talk to another human on Zoom or what otherwise, or Discord, or just chat up the mods. Just chill, because stress really, I don't understand people who say they work really well under stress. I hate stress. I work really well when I know what I'm doing. I don't work so great when I stress. Cortisol just clouds the mind, and it's good for getting adrenaline going in the beginning, but it doesn't allow good thinking. So if you're stressing out, back away. This is an InfoSec hacker event normally. CTFs normally are hosted at those. So expect security challenges, expect offensive challenges, like definitely web hacking challenges. You've got to know how to do some web hacking. Don't expect them to just kind of, especially if they're 15 points, they're not going to be spoon-fed yet. So let's go through some old examples of what we see here. So this was a challenge I made called You're So Basic. And a number of people saw it and some people didn't. And the big trick of it was base 64 times. And I laugh at it because it resulted in like a 1.2 gigabyte file that was just a text file. And I don't know if you ever try to open up 1 gig in a notepad, or any type of text interpreter, it will beat the crap out of your system. It'll eat all the memory. I've even heard a couple of people who open it crashed their machine. So I laugh a little bit at that. And I know when I made this code, it taxed the heck out of my machine. I had like a hexacore and I had 16 gigs of RAM. And yeah, man, it made that thing sweat. It did not function well. So when you run this stuff like that, if you run into a big file, don't maybe try to read the first few lines and see what it is. Unfortunately, with that one, reading the first line, it was 1 perpetual line. So maybe you read the first couple, several dozen characters and get an idea what you're looking at. But yeah, you look into those big files, you're meant to use a tool or write a program to interpret them. So right out the gate, that's a good thing to think about. And so this is Python. A good thing to look at. Definitely always kind of have a little if statement in there or some kind of check to look for the word flag, because that's when you know you got something. So yeah, output a little snippet or a piece of that and say, hey, I found a flag somewhere. And that'll help you kind of guide your code when you start to structure it more and more and more. Because you may not know how long do I have to go? Oh man, I've gone 32 times in this. I'm still got this massive string. You gotta definitely write a for loop or while loop. Just try to write out the code and just kind of, like we say, throw things against the wall and go for that. But sometimes you got to make those little logical leaps. Like if they didn't give me anything else, and I know it's base 64, maybe it's a multiple of 64. Maybe it's 64 itself. So that's a fun little Python script that'll actually help you decode something like that. Great thing about program, take this code and mess around with it, change it, make it your own a little bit. I know sometimes it's the first hardest thing about writing a program is starting it, just like the first time writing anything is writing the title or writing the first sentence. So getting someone else's code and just kind of reusing it, reinterpreting it for your own purposes, it's great. So here's one that was a major challenge that nobody got, and I'm going to go ahead and open it up. This was called one-off composition. Nobody got this in the challenge, and nobody understood what it was. And the trick was, I don't know, some people may be looking at this and going, I think I know what it is. It's base 7, and it's all based off of this scale. So that's what I did. I took the flag, put it into an ASCII chart code, made that base 10 into a base 7, and I put them up as notes. And so this is what the end result is. So I tend to work them backwards. Take this flag, convert it into ASCII code, turn that ASCII code into base 7, and that's where I got the note ranges. So, just look back at this scale, and that's what it is. Yeah, it's deceptively simple, but just the way you look at it. Going back, so yeah, that sometimes these things they're just that interpreted a different way. Don't be afraid if you see something new or strange. It's an opportunity to learn something new. And once you get past that learning new thing, usually we reveal what it is. So I know we're already in the thick of it. We had our first day in CTF. We're gonna stop it at 4 p.m. But how do you prep for your next CTF? Now you can go right into it, blind, and then start going like, I don't know where to begin. There's that way, and that could be pretty painful. But I would suggest you do a little prep. And I've said a couple times, learn a programming language. Don't know one, now is a good time to start learning. I just gave you some Python. Go at it, use that. The Google is a fantastic tool to learn Python. Just how do I do this in Python? Write it out in English, and you can get amazed at what kind of answers you get. Stack Exchange has got a bunch of them. Just be sure to read. Definitely maybe use the answer, don't use the question. Tools, again, tools for basic stuff, and just kind of a quick overview. Google, YouTube, and those are great tools out there that people have made a huge effort to write up blogs on how to break things apart, or they've made YouTube clips on walking you step by step to how to do something. So, I know you want to talk to the mods, and we like talking to you, but asking us a question of, hey, how do I do this? We're mostly going to say Google. Go to Google. The tool's there for that. It cannot be said enough. If you have a question, and if it's not specific to the challenge, but if it's a process or a tool or how do I do this, Google is going to be your best answer. Web browsers. I already said it before. I said Zap, Burp, F12, view the source. That's going to be very, very helpful on those. But you're not, each challenge to be different because each programmer writes things a little differently. So there's no hard and fast rules on this stuff. It's just the tools, and you just guys take your time and understand what they're doing. I hope you're running on an operating system right now. You could be running on a phone or a tablet, but yeah, Linux and Windows, they've got tools underneath of them in order to do stuff. Linux, I think, has got a lot more. Sed, awk, grep, strep, strings, grep, the bar command. These are all very, very useful. Definitely learn them. Kali Linux, man, there's a bunch of tools in there. Definitely learn all the different tools in there. It's even got the rocku.txt file, which is basically this huge dictionary file. It's like 130 megs of known passwords, Wi-Fi things, or Wi-Fi codes. So definitely go through that. That Rocku is a very useful tool if you're trying to do a brute force on stuff. It may not always work though. So some tools, some websites to go through. TrailBits has a great intro to CTF 101. It goes into some things a little bit more in depth than I do. Forensics has got a forensics wiki on there. I think it's great. It goes through a bunch of stuff. Definitely something worthwhile reading. Code, it depends on your language, but here's a bunch of Python ones. There's a Bash one. You could do PowerShell. I don't know why. And PHP. Oh God, just don't write PHP. I'm looking at you, Brian. Don't write PHP, man. Ugly. But if that's the tool the program use it. Don't try learning a new language when you already got a good one there. I have issues with PHP. So a reverse image search. If you're looking at something and you don't know what the heck it is, take a screenshot of it, put it up on reverse Google image search, and maybe it will give you something. Like, what is this text? I don't know. Oh, hey, that's Sanskrit. Okay, cool. It gives you the hint of what you're looking at. CyberChef. I've said it several times. This is a link. You can go to Google, just type in CyberChef. It'll get you the link. That is a fantastic tool. It gives you a bunch of things of how to convert stuff from base 64, base 32, quick tools to decrypt stuff if you have the key in IV. Yeah, it's a great tool. Play around with it. And if you're done with this and game's over, go to Hack the Box. That's a great constant CTF. It is a lot more real world. You are definitely trying to break into a box multiple different ways. That is a great site. Go in there, test your might, man. It's fantastic. I love the challenges on it. And the CTF's already started. So keep going at it. If you haven't started, now is the time. Don't worry about winning. Just learn and have fun. And that's really what it's about. We all like prizes, but really, I think we're all here for learning and having a good time. So with that, I don't know if we have anyone in here, if anyone wants to ask some questions, or do we even have any time?
We have time for one quick question that came up. So one person asked, when starting out with CTFs, is it better to try them by yourself or find a team to join you?
Yes, both. Don't be upset if you don't have a team. You can learn a lot on your own. You don't. I think there's like an old African saying: if you want to get there fast, go it alone. If you want to get there, go as a team. So I think I might be totally messing it up, but the idea is that you can travel really fast by yourself. You can make these crazy logical leaps. You can jump all over the place and go over the place and not have sit there and try and explain things to people. So it could be really good to do it by yourself. But if you're in a team, you can throw things against each other and get new ideas. So I think a team is a great option, but probably for your first CTF, maybe just try it by yourself, get a feel for what you like about it and where you have fun. And then maybe just build a team around that that likes the same stuff that you do, but has diversified skills. You don't want everybody who can do the same thing. You bred in weakness. You want strength. You want diversity.
Cool. All right, and that's all we got time for. And I appreciate it, Brian or Brad.
Okay, Sam.
Thank you. Have a good one, and thanks again for speaking.